So the acronym of the day that we're all familiar with is PFAS. PFAS refers to a chemical in water. So naturally, my guest today is the man who wrote the book on water law in Wisconsin, Paul Kent. Paul, my first introductory question to you is, was that acronym even in the book a few years ago?
No, certainly not. I mean, this is something that has just burst on the scene. Even though these compounds have been manufactured and used since the 1940s and are everywhere in our house, this is something that has only really become an issue in the last couple of years.
And on this issue of the local perspective, we're going to talk about PFAS, what we know, what we don't know, what we need to find out, what we perhaps shouldn't be worrying about quite as much, every question that we can come up with. But first of all, Paul, thank you very much for being here.
It's a pleasure.
I have to tell my viewers that in addition to literally writing the book on water law in Wisconsin, the title of the book is?
Wisconsin Water Law in the 21st Century.
Ooh, we've updated it.
Yes, yes.
But Paul did write the book, or does write that book regularly on the state of water law. And you have a tremendous history and experience. You teach water law for the University of Wisconsin. You've been associated with issues relating to tribal law, mining. You've sort of been there and done that and seen that, I trust.
Yeah, and I right now, my practice over the last 40 years has kind of evolved, but the real focus of my practice in the last 20 years in particular has been with municipalities. And water issues associated with municipalities, particularly wastewater, drinking water, wetlands, and stormwater issues for municipal utilities. And I work with an association called the Municipal Environmental Group Wastewater Division, which is an association of about 100 communities statewide that own and operate wastewater plants, and our office serves as both legal counsel and lobbyist for them on issues involving legislation or rules. And in this last year or so, it's been a lot about PFAS.
Well, and I was just thinking to myself, and for the last decade, it's been phosphorus, it's been nitrates, it's been, these agricultural interface issues. But now all of a sudden, kaboom, you're dealing with this thing called PFAS. So let's dive into it. What are they? Let me see if I can do this. Polyfluoroalkyl substances. That's what PFAS means, right?
Right. I will just say PFAS.
You'll just say PFAS. Yeah, we'll all agree. We're going to stick with the acronym today, folks. Forgive us for that. And unless that's your mom, we'll just keep going.
We'll keep going. Yes, my apologies. One of those things I failed to check before I came in.
And if that's the mayor of one of my members and I'm in trouble, it's my fault.
Just have to wait. But these are compounds that involve carbon and fluorine, and it's actually, without getting too much into the science stuff, one of the strongest bonds in nature. And because of that, they're very useful products. They are heat resistant, they are water resistant, they are resist oils and greases. And so they have had a variety of uses. And one of the more notable uses has been firefighting foam, and that's received a lot of attention. But they're everywhere. No-stick frying pans and Scotch Guard and fire-resistant clothing, Gore-Tex and boots and cosmetics and insect repellent. And it's amazing how many different products that are in our household use one or more of these kinds of substances.
And then the next question is, okay, so what's the problem?
Well, the problem is that when these compounds, kind of get into the dust or the air or water, there have been recent studies that have shown there's adverse health effects. And exactly the extent of those effects is something that is still in the process of being studied. But there's effects to the immune system. There have been particular concerns about kidney and liver and some developmental issues. And as with many things, it's this more sensitive populations that are driving some of those concerns. But we're just at the front end of really understanding kind of what those effects are and what levels trigger those kinds of effects.
Well, a few weeks ago, I was out in Washington, D.C. at a meeting that the National League of Cities put together with a group of scientists and public health officials. I think the other sponsor was the American Association for the Advancement of Science. And the two things I finally asked, I said, you see all these health studies, and virtually every one of them is inconclusive. And I said, I get that. We want to be cautious. We want to move forward. But this is a freight train from a regulatory perspective. I mean, there's determination to pass strict water quality limits virtually immediately. And I asked scientists the questions. I said, okay, I get, if there's an urgency here, but why the rush? Why are we so far ahead of the science? And the one response that I got that made sense to me was, there's two things they look at when they decide to regulate. One is toxicity, known toxicity. The other is, and I forget the term, occurrence. And the challenge with PFAS is that it's in 95% of our blood. So it's not so much that we know it's killing you, causing cancer, giving me gray hair. I personally think that's why my hair is falling out. But it's that it's everywhere, and that's a cause for concern. Is that an accurate way of putting it?
Well, I think the observation that it's everywhere is true, and it kind of follows that, when you have it in so many products, you're going to find it in other ways. So household dust. We have studies showing, several parts per billion in household dust. As you know, the human blood in our country has it. They've even found it in some rainfall. They have found it in national park forest land. These are not
where nobody's been.
Where nobody has been. And so, I think one of the challenges of this is to recognize that there are, if you will, background levels of this that are out there. And what we really need to focus on is, what are the levels that are really of public health concern? At what point does that become a problem for drinking water? What are the exposure pathways that we need to be looking at? And that, unfortunately, I think takes time. I mean, in one of the more recent legislative debates, we had somebody that says, well, we have to act because we don't have time to do the science. And, I think, I get the fact that people want to do something. We're in a culture in particular where everybody wants something done right away. But it's also important to do them the right way and to make sure that we have the science so that on the one hand, we're protective enough that we don't set a standard that doesn't protect public health, but that we also don't overreact and require things, particularly of our municipal utilities, that are things that don't need to be done and are too costly.
Well, and I want to come back around to the testing, but maybe we can get to that a little later. Since you brought up the focus on municipal water and wastewater systems, I guess my question is, if we make the decision we don't want this stuff in our water, what are the options for removal, and do you have any idea what that's going to cost?
Well, and it's a little different for water and wastewater. I'm more familiar on the wastewater side. And, and I think it's important to realize, municipal wastewater utilities, we don't use PFAS.
We didn't put it there.
We didn't put it there. I mean, it's not like chlorine, where we disinfect with chlorine, or that we put in a polymer to settle solids. We're not using PFAS. It's not something that's part of our system. But because it's so ubiquitous and it is used in a lot of different products, wastewater that comes to us is likely to have some PFAS in it. Now, the problem from a wastewater perspective is The treatment options are reverse osmosis and advanced carbon filtration. And without going into all of the technical details, which I'm not really qualified to get into anyway, I can tell you that the costs of these are enormous. We thought phosphorus cost a lot. My goodness.
Phosphorus does cost a lot.
It does cost a lot, but this is orders of magnitude higher than that. And it's not just the capital cost of massive RO filters or carbon, but it's the energy costs as you run, say, 20 million gallons a day through these filters. And then once you've done that, you have residuals. You have a waste that now has much more concentrated PFAS and other stuff in it that you can't just take to the landfill. You're shipping it out to specialized waste treatment facilities.
Didn't Marinette, this is a public record, so I'm not revealing any secrets. Didn't they spend $2 million trucking soil to the state of Oregon to be burned?
Right. There's very few places you have those kinds of costs, and Marinette, while a good-sized city, if you think of what that would cost for, a city the size of Madison to undertake that kind of effort, the costs are pretty staggering. So, now at the end of the day, and this is where it kind of gets back to the question of what do we need to do. Municipal utilities, water, wastewater, we're in the business of protecting public health and the environment.
Absolutely.
That's what we do. And the people that run those take great pride in that. And if, in fact, that's what we have to do, we'll figure out some way to do it.
But Paul, I'm sorry, you finish your thought.
Well, but what I was going to say is the flip side of that, given the cost, the energy, the dollar cost, the waste disposal issues, we don't want to be doing that if we don't have to, if there's a better way to do it. And really the better way to try and get at this, in our view, is to prevent the stuff from coming into our systems. That's a little harder on the drinking water side because it's typically in groundwater, and I'll get back to that in a minute. But on the wastewater side, we've done stuff like this before with things that are hard to treat. Mercury, another example, something that's ubiquitous in many respects. But we found that there were a few concentrated sources that we could target. So we went to dental offices and said, could you separate your amalgam? We went to schools and said, could you make sure you're not washing liquid mercury down the drain? We went to hospitals with thermometers. And over the course of 10, 15 years, our mercury discharges have dropped way below the applicable standard. So that kind of program works. I think we need to be doing some education and trying to get people to either product substitute or segregate waste streams so that it's not coming to us. And I think that's really going to be the best that we can do with this at this point.
Well, and I'm trying to figure out how to say this without getting too crude, but if you're cleaning it up once it goes through the sewer system, aren't we sort of doing that on the back end? Instead of what we should be doing is preventing it from getting into people's lives in the front end?
Absolutely. And it's
I did say that carefully
You
enough.
did say that carefully, and but that is it's what in the wastewater we're talking about, things outside the fence. What can we do to help manage what comes into the facility and manage it at the front end rather than treating it and dealing with the residual at the back end? And that, even that residual can be, create its own problems. If it goes to a landfill and it gets into the leachate, where do you think the leachate goes? That comes back to the wastewater plant. So we need to be looking at stuff at the front end. We need to be looking at things holistically. We can't just be trying to target things, where they end up and think that that's the solution. We need to be looking at that more holistically.
My guest is Paul Kent, an attorney with an expertise in water law in Wisconsin, and we're talking about water, so therefore we are talking about PFAS. So Paul, let's talk, we've talked a little bit about wastewater. Let's talk about drinking water, which, obviously we want to provide people with the purest, cleanest best drinking water we can. Again, going back to Marinette, they draw their water from Lake Michigan. Even that water, which is miles away from firefighting foam and any other contaminants, they found 1 part per, is it gazillion or what's that?
Trillion.
Per trillion. That's less than that. But my point is, to your point earlier, it's ubiquitous. It's everywhere. First of all, how do you measure 1 part per trillion? You can't do that with tweezers.
No, and I keep telling people I went into law because I couldn't do math, but I've had to learn a little math along the way.
That's why statutes are numbered the way they are.
I know, it's crazy. But so there are, a trillion is a million million. So when you're talking about 1 part per trillion, that's the equivalent of 1 second in 32,000 years. It's really small. And we're talking now about standards that are in that parts per trillion range. The one kind of national standard on public health is a public health advisory that EPA issued on drinking water at 70 parts per trillion. Our Department of Health has issued a recommendation for a groundwater standard at 20 parts per trillion. But these are very, very low numbers. And, one of the issues that, of course, raises is the testing and the testing protocol.
Right, because I imagine you have to be a fairly sophisticated laboratory to be able to, if it's everywhere in the environment, to be able to get a sample that's truly a representative sample and not you brushing Scotchgard off your jacket is a bit of a challenge.
Right, and actually some of the testing protocols Michigan has developed some are exactly that type of thing. You can't have had fast food in the last 24 hours. You can't be wearing Gore-Tex jackets or shoes. You can't have washed your clothes in fabric softener. You can't have cosmetics in the last 3 days. I mean, it's a testing protocol just to collect the sample that is daunting, but it's exactly for that reason. Because they're so ubiquitous, you want to make sure that what you're testing is in the soil or the groundwater and not coming off of all of the things that are around you.
Now we're talking about what I hope is sort of on the extreme cautious end of the spectrum. There are places in Wisconsin, are there not, where we've tested firefighting foam, where we've done a lot of concentrated work. Can I call them hot spots, where the level is quite a bit higher than that?
Well, and I think that's true. Yeah, the answer is yes, and there are some places where either because they've been manufacturing sites for firefighting foam, as up in the Marinette area, or whether they are Air Force bases that have used that kind of foam as part of their drills, and so you have a buildup over time. And so you have these places where it's more concentrated, and that's really not any different than any other kind of environmental contamination that we deal with. It's just a different substance, and I don't want to minimize the public health aspects of this as opposed to petroleum or dry cleaning solvents, but it's the same kind of thing. You've got concentrated areas that need to be addressed.
And is there general consensus about that the hot spots need to be addressed in some manner?
I think so, but here again, this is part of the problem of this bursting onto the scene. The data for what are safe levels to protect public health is just at the infancy. So the question is, so you can test it, you can find it, and chances are, because it's ubiquitous, if you test it, you will find it. If you build it, they will come. Well, if you test it, you're going to find it, kind of thing.
Yeah, we can even borrow from the Bible.
Yeah,
seek and you shall find.
You shall find. And so
I don't think that's what God had in mind, but
the question is, what does that mean? What does that number mean? You find something in the soil at so many parts per billion. We don't have a good sense of what that means, and one of the things that we're trying to communicate to the public is you can't take a groundwater standard, whether that's 20 parts per trillion or 70 parts per trillion, and say, well, then that's what has to be for surface water and for soil and for remediation and biosolids and other kinds of things. The PFAS operates differently in different media. The exposure pathways and the health risk effects are different in all of those cases. So what may be an appropriate number for drinking water and a direct ingestion is probably not the number that comes into mind if what you're doing is encountering it on, you know, a farm field, or if you are encountering it in surface water. So getting back then to the hot spots, the question there is, okay, it's not background, but what's the number?
How clean does this site have to be?
How clean is clean?
Yep.
What is acceptable? And that's a real challenge because we don't have those numbers yet. And so, you know, I think what we're seeing is that people are taking, you know, a cautionary view of some of this, and that's fine. But I think it also is starting to impose some costs that may or may not be necessary in terms of protecting public health.
So along that line, and our audience is primarily municipal leaders, and they're hearing about this, they're reading about this, while the scientists and the lawyers sort of battle it out in Madison, if I'm running the waste treatment system in Osseo, what should I be, is there anything I should be doing today? Is there something I ought to be thinking about? What's your advice? And I know it'll be different for every one of those systems, but.
Well, I think there's a couple of things. One is, I mean, I think you need to be aware that this is an issue. And even though there aren't standards, it is clearly something that's in the public domain. It's something the Department of Natural Resources and others are paying attention to. What does that mean? I think we can be proactive in terms of reaching out to members of the community that may be industries, for example, that might be using this as part of their manufacturing process or cleaning process or something else, and starting to explore ways to educate them and to suggest that, you know, minimizing the use of those products and the discharge of wastewater with those, it's going to help us, it's going to help you. So I think doing something to try and start getting outside the fence is helpful. And I think the other thing is that I think we really need to take more of a proactive view in getting good information out there about what we know and what we don't know about PFAS, because I think it's easy to become concerned and to misunderstand, you know, the differences between all of these numbers and what does it mean. I think we need to provide some context for people so that they understand that just because you find it, it doesn't necessarily mean it's a problem, but that here are some things that you need to be aware of and things that you can do.
And I should say here that the League, I'm going to look over to Gail Sumi. Gail, the League is providing the best information we can find on this on our website. Yes. Are there other good resources or sources you would point people to for information that doesn't try to sweep it under the rug, nor does it try to say, oh my God, the sky is falling, run away, run away? I want that stuff in the middle.
Right. Well, you know, it's trying to be factual, and it's trying to provide context. And you guys have done a good job. As you know, there is a municipal water coalition that has formed with the League, with the Municipal Environmental Group, Wastewater Division, and Water Division with Wisconsin Rural Water. And one of the things that we're working on collectively is trying to provide some of that context that we're going to make available to members, and we're hoping eventually that DNR can be doing a little better job of providing some context on their website as well.
At that workshop I attended in Washington, I was sitting next to an engineer who's working for the American Water Works Association, and her contract is to develop that information. So for those of you that run water operations, help is on the way. I hope the same is true for wastewater systems. Paul, we've got about, a little more than 3 minutes left, and I want to kind of step back and say, okay, what did we learn here? Was this a mistake? Was it just we didn't know any better? We didn't know we didn't know? But more importantly, going forward, what should that tell us? What should it tell society about how we introduce new ideas into our lives?
Well, I think that, we probably need to be doing a better job at the front end, thinking about what all of these chemicals that are part of our products have in the way of, potential effects. That's a pretty fundamental change in our economy. I don't know if that's going to happen. But, I think to the extent that we do become aware of, compounds that create these kinds of things, I think we really do need to take a breath and let the science work. I continue to be concerned that there is such whether it's a political or a societal need to do something because it's a problem, that we jump to a solution that may be irrelevant or even counterproductive without really understanding the science. And I think, measures that were introduced in this last legislative session to require DHS to promulgate a standard within 90 days, I think is emblematic of what we shouldn't be doing. Mm-hmm. I mean, I think we need to be thoughtful and cautious. And probably what that means is also having the resources available at the Department of Health and DNR to do this work. As far as I know, there was one person at DHS that has the responsibility for developing all of this stuff. Personally, I think that that's probably not adequate to deal with, the kinds of things we might be looking at in the future. Building up some science capability within our agencies so that when something comes up, we have the resources to do the science and to come up with the solutions, I think is going to be pretty critical.
In this case, I was talking to the mayor of Marinette, Steve Genesot, and Steve said, look, we're already in it. Everybody knows we're in it. Use us as the laboratory. His response was, come on up, do all the testing you can possibly think of. Now, I don't know if you represent Marinette or not as a lawyer. Maybe that makes you a little nervous. But the point is, to your point, let's dig into that science and dig into it rapidly, right?
Yeah, and I think part of it, too, gets back to this idea of context. For us to just test and generate numbers doesn't do us much good. I mean, we need to understand, to say that there is this level of PFAS in your blood, well, is that a good thing or a bad thing? That there is this much PFAS in wastewater. At what point does that become problematic? And so I think that what needs to be done is the science on what are the impacts, and then some context so that people understand that we don't live in a world where there is no PFAS or no impact. We have to figure out a way to come up with standards that make sense.
And I just realized we're out of time. My guest is Paul Kent. This has been The Local Perspective. Thanks for joining us.